Hi everyone, today we are going to discuss and implement BFS algorithm in graph. Basically, this comes under the graph. BFS is stand for breadth for search algorithm. So, firstly, what is the why BFS? So, breadth first search is an algorithm for searching the tree data structure for a node that satisfy the given property. Starts at the tree root and explore all the nodes present in the depth prior to move on the nodes on the next depth level. For example, the first level of this node is 0 and second node of the second depth level, all nodes are 1 2 3 and the third one is 4. So we need to print a value according to the BFS. So first node is 0, we print a 0. So after that 0 is linked with our 3 nodes. So as we can see here 1 2 and 3. So we need to print in that order: first level, second level and third level. In first level 0 and the second level is start 1 2 3, and after that the third level is 4. So we need to print 0 1 2 3 4. So as we can read here, which is saying the same. So 0 for 0 nodes, we can see here there is no node presented except 0. So we print a 0. So 0 is connected with 1 2 and 3. So we have to print 1 2 1 2 and 3. So after that we can see 2 is connected with 4. So we need to print a 4. 4 is comes under the third level. So basically BFS algorithm to print a traverse a graph with under a level, under under a level uh, statement, like the first level, then print second level, then print third level. So this is the how BFS algorithms want to trace values. So let's jump to the algorithm. So for solving this issue, so we need to follow some algorithm. First is to take a queue, push a node linked to that node. So basically we take a queue, so where we push our node value in it, and second we take a visit vector in which we store the this node is visited or not. So we can prevent from looping, or we can say that prevent from duplication. So we can use this vector visit vector. So after that we can use this two data structure to solve this issue. Firstly, as we can see here, firstly we need to push push a value in queue and check if this value this node is already visited or not. If visited, we don't print push that value in queue. And so if it's not visited, so we push a value in queue and update the visit node is true. So and also we push that value in our answer vector. So this is how this algorithm works. So let's jump to the coding section so we can more understand the algorithm. So we can see here, so for saving the time, where I'm already coded it on ID. So as I said, so we need to create a vector of visit, so we can store the information this node is visited or not. So the size of a visited vector is same as the number of vertex in a node. And second, we need to create a queue. So with the help of queue, we can push a node in it and pop the element as the level, printing as a printing level approach. So as we so third vector, so vector we can store our answer in it. So as I said, firstly we start a root. So we can start with pushing 0 in our queue and mark a 0 visit 0 node as a visited. So we run a while loop till the queue is empty. So as the first element already inserted as a 0, so this loop going to be true. So we just jump to this. So when we jump in this while loop, firstly we need to pop that store the element in a queue and store in TD. So as there is it means the TD, it means the font of the queue value is not present in our answer, and also not present in our visited, already present on our visited. It is starting point of the node. So we pop the value from the queue and push this value on answer, because TD is the unique node in our visit in our visited vector. So after that we take a for loop. So for loop for loop to visit all the node associated with the node. So there we can see here input input is given in adjacent matrix adjacent vector. It means we have a node 0. So in the node 0 we will find there are three nodes associated with the 0. So this is the how adjacent matrix. So I recommended that research on it about the adjacent vector. So we will know the how this vector we store the information we store the data in adjacent vector. So we start from x. So for example, we run our firstly we start with the for first element for let's say 0. So we can check a zeros connected all nodes. For example, we check for 0. So as we can see for TDs in TD stored as 0, so we check the all nodes which is associated with the 0. So we check first node of the 0 is 1. So we can see 0 is not present in visited, so we just comes into the if condition. So we can firstly mark this one node as a visited and push our this value in our queue. So when so after that all we can push all the nodes which is associated as 0. So then jump to the 2. So we can also know the 2 is not present on our visited list. So we can push this 2 in our queue, and then the third jump to the third node which is 3, which is also not visited in our visited vector. So we will push this node queue. So once this for loop is completed, now we are jump to the loop again. So now the current value in a queue is 1. So we pop the value front value of the queue is 1. So because 1 is the first node is associated with 0 and we stored in TD, so we can now pop that queue value one top pop from the queue. So after that we push our push back, we push our 1 in our answer vector. So now we will check the one nodes associated with 1. So we can see there is no node is associated with the for loop. We will stop here and we run for the second second node. So when we jump to the second node, so we store the node number 2 in TD and pop the 2 from the queue. So after that we push that 2 value in our answer set because 2 is not present in our answer. So after that we check a node for the 2. So associated nodes with 2. So as we can see only one node is associated. So just we check this 4 is visited. So which is, as we know there is 4 not visited. So we just jump just comes in this if condition. So we will first we push mark 4 as a visitor and push it over in queue. So let's jump now. This loop is completed. Now we are going to first line again as a queue is not empty. So the third after that the third value in our queue is the fourth value is 3. So we can store 3 in this and we push this the 3 value in our vector. So now after that after that we check for 3. There is no node associated with that and loop is completed. Now we again jump to the loop. So for that, so after that we will get our answer store in our v vector. So after that after running this algorithm we return this vector v, and as we can see here, so our output is just like 0, 1, 2 and 3, 4. So just click on submit button. So we will check code is executed or not. So as we can see here, code is test cases is passed, so it means our code is correct. So this is the how BFS BFS algorithm work in a graph. Thank you. Keep learning and keep watching my